right, the last key feature, one of the last, not the last, but one of the last key features we're doing is whether a function is odd or even. And it really is involving what you learned last year about reflections. If something is an even function, then it's like it has symmetry through the y-axis, so it's almost a reflection in the y-axis. And when it's an odd function, it has symmetry through the origin, which is it involves the reflections through the origin. So when a function is even, and if you want to determine if a function is even from a graph, a function is even from a graph if it is symmetric through the y-axis. So that means if you fold it along the y-axis, is it exactly the same? So that's what this looks like. If it was shifted over a little, it wouldn't be. An odd function has symmetry through the origin. So that means if you rotate it, if you take this and you rotate it 180 degrees, hold on, this one. If I rotate it 180 degrees, it's the exact same picture. Okay, so this is 180 degrees. It looks exactly the same. Intercepts are the same. Everything is the same. It goes the same end behavior. All that stuff is the same. So that would be an odd function. So the way that we do this algebraically, let's give you crazy there. The way that we do this algebraically is we use the fact that if we plug in something, a negative x, in place of x, if it's symmetric about the y-axis, it's just kind of, let's look over here. If it's symmetric about the y-axis, then you just take it and, you know, if I put in a 1, this point is there. If I put in a negative 1, that point is there. The y is exactly the same. Okay, that shows symmetry for the y-axis. And symmetry in the origin, if I plug in a 1, for x, I get 0. That's not a good one. If I plug in this point in here for x, it's 2 for y. But if I change it to negative of what that was, it becomes negative 2. So it kind of changes, the whole function gets negated. So that's what we want to do here. When we plug in negative x, so that's the key, we want to plug in negative x, do the math. If the function stays the same and there's no change, it's considered even. If the whole function changes, meaning that every sign gets changed, then it's an odd, and otherwise it's neither. So doing this, it feels a little crooked to me. So that's the process. So if I were to plug in, I have to plug in f of negative x. When I plug in that, if I get the exact same function out, x to the 4th minus 2x squared plus 3, then this is considered an even function. If it was an odd function, then the signs change. So x to the 4th is positive, so it would have to be negative. Negative 2x would have to change to positive 2x squared, and 3 would have to be a negative 3. All the signs change. So what happens? We plug in negative x in every spot that we have an x. Okay, do the math. Ooh, that should be a 4 there. Sorry. So do the math. You do have to remember when you have an even exponent, so if I have anything at all to an even exponent, this is just an aside here, to an even exponent, the result is always going to be positive. So if I square negative x, that's going to be positive x squared. And if I raise anything to an odd exponent, the sign will always stay the same. So this was negative, it's going to stay negative. Okay, so if I do negative x to the 3rd, that's going to be simply negative x to the 3rd without the exponent. Okay, so this is an even exponent, so that's going to be positive. This is an even exponent, also positive. So plus 3. So the sign, none of the signs change. So f of negative x is this one. These two match. So this is an even function. This one here, same process. If it was even, when I plug in f of negative x, I would get the exact same thing out. If I plug in f of negative x and all the signs changes, so if I get a negative x cubed minus 6x, then it is odd. So let's do it. So plug in negative x into every spot that there's an x. This is an odd exponent, so the sign stays the same. Oh. That 6 times negative x. All right, so this is sign change, matches this one, so this is an odd function. And then finally this one, you want to guess what this is going to be? If this is even, then when I plug in f of negative x, all the signs, everything should stay the same. If it's odd, the signs change. So this is just reference. You don't necessarily have to write this mess out. I'm just trying, I'm the teacher at this point, so trying to make it as clear as possible. So all the signs should change. So this was a positive to negative, negative to positive. So let's plug it in. F of negative x equals negative x to the 4th plus 2 negative x to the 3rd minus 3. Even exponent stays positive. Odd exponent, this is negative x to the 3rd. So 2 times negative x to the 3rd is negative 2x to the 3rd, and then minus 3. So this one right here doesn't match either of these. It has to match it exactly, so it's neither. Have a nice day.